Let's talk about trigonometric ratios in right triangles. Now, trigonometry is the relationship between the sides and angles between those sides. Here I have a picture of a right triangle. This is our right angle, and this is an acute angle. We name the sides based on these angles. So the hypotenuse is always the side opposite the right angle. The adjacent side is the side next to the acute angle, and the opposite side is the side opposite the acute angle. Now we have 6 trigonometric ratios we can identify. We have sine, cosine, tangent, cosecant, which is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. This is how we identify our 6 ratios. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. Cosecant is the reciprocal of sine theta, so it is the hypotenuse over the opposite. Secant theta is the reciprocal of cosine theta, so it is the hypotenuse over the adjacent. And cotangent theta is the reciprocal of tan theta, so it is the adjacent over the opposite. Now we can use the lengths of the sides of our triangle to help us find the ratios. So sine theta is 3 over 5. Cosine theta is 4 over 5. Tangent theta is 3 over 4. Cosecant theta is the reciprocal of sine theta, so its ratio is 5/3. Secant theta is the reciprocal of cosine theta, so its ratio is 5/4. Cotangent theta is the reciprocal of tangent theta, so its ratio is 4/3. Now here I have an example of a triangle where we want to find the 6 ratios, but we're only given 2 of the sides. We have the side of the hypotenuse, which is length 13. We have the side of one of the legs, which is 5, but we don't know this adjacent side. Now we can use the Pythagorean theorem to help us find our missing side. The Pythagorean theorem formula is a squared plus b squared equals c squared. A and b are the 2 sides, and c is the hypotenuse. So to find the missing side, we can substitute the information we have into the Pythagorean theorem. So we're missing a, so we write a squared. We know the lengths of one of the sides, so that's 5 squared. And we know the length of the hypotenuse, and it's 13 squared. So using a little bit of algebra, we have a squared plus 5 squared, which is 25, equals 13 squared, which is 169. Now we want to get a squared by itself, so we're going to subtract 25 from both sides of our equation. And now we're left with a squared is equal to 144. Now to find a, all we have to do is take the square root of both sides. So the square root of a squared is equal to the square root of 144. Therefore, a is equal to 12. So now that we have the length of our missing side, which is 12, we can now write our 6 ratios. Sine theta is 5 over 13. Cosine theta is 12 over 13. Tangent theta is 5 over 12. Cosecant theta is the reciprocal of sine theta, so it's 13/5. Secant theta is the reciprocal of cosine theta, so its ratio is 13/12. Cotangent theta is the reciprocal of tan theta, so its ratio is 12/5.